What is up, most distinguished patrons of this channel? Today I got a treat for you, and that is we are going to look at the guts of this Fronius battery powered welder. That's something I didn't do in the previous video, and by the way, if you haven't seen that video, link in the description, where I talk about what this is, which is basically a battery powered cordless welder. That's awesome, by the way. And if you want to learn more about that, go and watch that video. We're just going to look at the internals and the thought process that went behind making this. And I've never seen the inside of a Fronius for myself, and well, the pictures online never show what's inside of here, so I'm very curious. So that's what we're going to be tackling today. Let's get into it. So I put this container topper down just to kind of isolate this sucker from the big heavy hunk of steel underneath it. Not that I think it would instantly discharge for any reason, but hey, if you're going to be dumb, at least be somewhat smart, right? And speaking of that, this is not like a normal welder that has no juice in it other than maybe stored energy and capacitors when it's unplugged. This has a battery pack that stores a tremendous amount of energy at fairly high voltage as well. So it is far more dangerous than what you would normally find in a welder. Now, I'm sure this thing is engineered to where it's not completely janky and unsafe. Reason being that, well, if it was, it would probably short out if the air that it's pulling through it had high moisture content or etc. You get the picture. But with that said, I believe I got all the screws out. So I'm just going to pry this apart gently and then lift the center case out. Looks like it's going to go. And we can see what's in here together. So first thoughts, this has more in common with a modern day computer than what you would expect to see. And it goes without saying that this sucker is far more than just basically a battery pack and two output leads. Like basically it's two car batteries and a set of jumper cables, which is kind of awesome in some respects and scary in others because, well, how serviceable this is, I guess we're going to find out by the end of this video. Now this is this side. It has some computer boards, appears to have a couple transformers in here, which is kind of interesting, or they might be using them as inductors. I'm not really too sure. I see capacitors, I see all sorts of stuff. Let me rotate this. And, well, there's not much to see here. The battery pack is located right inside of here, and oddly enough, through the side, I can see it's made up of individual cells. So this is not a sealed, like kind of lithium battery pack where it's like, how do I put it? Like pouch type pack. Off camera, I'll have to look a little bit better, see if I can get some sizes on those cells. This says BMZ nominal charge voltage, 52.8 volts, 7.5 amp hour. By the look of it, this may not be manufactured by Fronius, but more or less they pay somebody else for it. It is made in Germany. Does not list anything other than lithium ion, iron phosphate battery. So pretty simple here. Let's go back and look at the other side. So interestingly enough, basically this is the welder. The whole other side of this unit is just the battery pack. So half of it's battery, half of it's welder. Now the serviceability of this unit is probably pretty decent from a standpoint. All of these boards have numbers on them, and you could probably contact Fronius and get a replacement if they would be willing to sell you a replacement. Keyword if. Now the components on here aren't really user replaceable. Like if you had a bad capacitor on here, you could replace it, but the rest of it being all, chip on board here, it's going to be pretty difficult for the average person to repair anything in here. It's not like an old transformer machine where the things that would generally go wrong are easily replaced. This is a very simple design by the look of it, which makes sense because in a normal welder, you have essentially your AC coming in and it has to rectify that into DC for output if it's a DC welder, and it needs transformers to change the higher voltage from your wall to lower voltage welding output. So it's an average welder is actually pretty complex, especially modern inverters. Well, this thing essentially doesn't need to rectify anything AC-wise, because there is no AC in this to begin with. It's dealing with DC current from batteries, so it only needs to take that DC and essentially control the amperage from it so you don't just strike an arc and blow the rod up by outputting max current in a direct short. So most of what we have in here is essentially current limiting, specifically for stick welding. Now this unit is also a TIG machine, so it's going to have circuitry for the TIG functionality of it. Now this does not have high frequency start, and I don't see any evidence that that was ever a thought process behind this, because, well, for one, it doesn't have a high frequency arc starter, but this does have adjustable amperage on the TIG torch where you can rock a switch and control amperage. So that's part of what the computerized system in here would be used for. This is also likely compatible with a foot pedal for amperage for TIG. So again, you need circuitry for that. And then of course you need circuitry to adjust your hot start, your arc force dynamic, and all of that. But realistically, this is probably the most simplistic design for a TIG welder that you're ever going to see. Everything else out there, unless it's an old transformer machine, is far more complex than that, than what you see here. Now, I'm not really sure what is in that right there. It seems to be an aluminum heat sink, so that's quite interesting. And speaking of heat, this appears to have two fans back here that blows air straight through this and basically straight through the battery pack, because a battery is really what's going to get hot more or less in here, since this does not need like IGBT modules, I don't think, to really do anything, because again, you're dealing with DC current already, so it vastly simplifies the design of it. Now, from an engineering standpoint, I really like what I see here. When you see stuff like this, where it has everything zip tied, there's cord retention built in, every component has a home like that it clips in, same thing over there. This looks like a well-built machine. You don't see like sketchy stuff going on in here like I have in many other welders that I have opened up, so I like that. Now, I wish I knew more about some of the components that are in here, like these blue things over here. I'm not exactly sure what they are. They could be capacitors of some sort. I'm sure I could look the number up online and figure that out, but for the sake of this, I guess it really doesn't matter. Let's look at some of the other components. So this little guy appears to be an inductor of some sort. It could be used to smooth out DC, although I doubt it. This guy over here looks more like what's called a welding reactor. I'll zoom in on that. It's pretty hard to see, but this little guy in here might be a form of a welding reactor that smooths out DC, which I'm not really sure why it would have one of those, because like I said, it doesn't produce AC in any capacity that I'm aware of, but that's commonly done on machines to smooth out the DC ripple. Well, there probably wouldn't be much of a ripple, being that this runs off a battery, but again, it might be used as an inductor for something else, some other purpose. But again, I'm not an electronics expert, and this is kind of a little bit above my pay grade per se. So inside of the front, you can see there's a little USB adapter, which you can actually access from the side. That's probably for programming or whatever at the factory. And this is the main connector that connects the battery pack inside of there over to the boards. I believe this has individual cell monitoring, or at least if the battery is set up in cell blocks, it can likely monitor the charge status of the individual cells or cell blocks. So it is a fairly intelligent system. Part of the circuitry you saw on the other side would have been battery monitoring and charging, I believe. Although it is possible that the charger itself that plugs into the wall monitors all of that rather than the circuitry in here. I'm not exactly sure. So I got the look in here, and this group of wires comes to the charging port. So I have a feeling the active charger itself monitors the cells and the charging of them rather than the onboard circuitry, which honestly makes sense, because why would you really want to carry around the electronics that does that in here when you don't need them because you're not charging it. So it would be extra weight and extra volume that would just take up space versus a charger can do it for you. So that totally makes sense, and that's kind of an intelligent thought if that's what they actually did. And space is at a premium in here. There really isn't that much dead space. I mean, the little bit of space you see here, really you kind of need that, one, for somewhat of a heat dissipation, and two, to in case the case gets knocked a little bit, that it doesn't short out on these components at all. Which, speaking of that, let me look at the inside of the case over there. So interestingly enough, there is not a plastic shield on this case or internally that shields lugs from a short, which is kind of interesting because every smaller welder I've ever taken apart has a plastic separator either inside or on the case to prevent a direct short. Now, in my case, had I been an unlucky bastard when I was removing this lip up here could have caught one of them terminals, like that red terminal right there, or one of those, which are likely live direct with battery power, and it could have instantaneously shorted out and welded something in there. So that's pretty interesting. Now, maybe those aren't live when it's turned off, but that's kind of surprising. And not to mention, if you knocked a hole, or not a hole, but a dent in the side of this, there isn't maybe, I don't know, under an inch that it could touch a live terminal and then short out that whole battery pack. So again, maybe it has some kind of protection where it's not a direct hook from the battery to any of these terminals and there's an actual relay or something. I don't know. I'd have to disassemble it, but I find that a little bit surprising. Beyond that, I mean, nothing really looks too janky in here, surprisingly. Well, why would it be? It's an expensive machine from a well-known company, you know, so the engineering's pretty good. All right, well, let me put this back together and let's go and look at the charger. So here is the active charger, and this is the brains of the operation. I would say without a doubt, this is what monitors the charging. And the reason I say that is it has a 6, 8, 9, 10, at least 10 pin connector on here. And obviously if all it had was just positive, negative, it would be just a charger, but this must monitor at least cell blocks in the machine itself for charging purposes, which is good. Now, this has a lot of caution, danger, electric shock. Obviously, you don't want this thing plugged into the wall if you open it, and not only that, it probably shouldn't be hooked up to the machine either. And I'm going to be very careful taking this apart in the off chance that there's capacitors that are charged. And I said it kind of earlier, and I'll say it again. Don't be an idiot. When you're taking apart stuff like this, if you don't at least have any idea what you're doing, you're liable to get hurt. And I'm not saying I'm a qualified individual, but I will say I've been pulling apart TVs since I was about 6 years old and somehow managed to make it to adulthood. So maybe I'm just a better idiot than the average idiot, but just don't hurt yourself, please. With that said, I think I just got to pull these rubber isolators off of this and then we can take it apart. I am going to go grab my plastic table topper just in case. So this sucker was a little bit harder to get apart than the welder, but it still came apart pretty decent, pretty easy. Really nice extruded aluminum heatsink slash case. I'm sure that this is proprietary and Fronius didn't just randomly buy off the shelf extruded aluminum like this. It's pretty unique. Anyways, by the look of it inside, we have a double transformer, so 2 separate transformers. And this device really is designed to take your AC wall outlet, which here in North America is 120 volt, single phase, 60 hertz. And I've heard that this will run on a lot of different voltages and a lot of different frequencies, so 50 hertz as well for you guys that are out of North America. But not that this out of the box will, but the same design, I guess. It's got a lot of leeway in the design. Well, Fronius is an international company, so it totally makes sense. Which, by the way, a lot of American welder companies, they kind of take the screw you approach to all you guys overseas where they don't export their products and they don't design their products to work on anything but the North American power grid, which I'm more or less the kind of guy I'd rather make stuff for everyone, but hey, I can't change American companies. But anyways, seems to be a fairly simple design internally. Really all it does is take that 120 volt wall power and convert it to DC power to charge the batteries. There does appear to be a couple computer chips and of assorted varieties in here. And again, I'm no electronics expert, so don't hold me accountable when I'm wrong. I'm wrong a lot. But I guess simpler than what I expected. I expected like a single transformer and a big computer chip, a couple capacitors, and I guess in a sort of it's like that, but there's a lot going on in here. And I gotta say, I like the way that this whole heatsink is set up and the way that stuff is mounted. It's mounted through the board and directly touches this aluminum heatsink on the bottom by the look of it. So the cooling on this is going to be very good. And it also has a little fan you can see in the case right here, so that helps with cooling of the components in here. Overall, not a cheap design, likely functions very well and will be pretty reliable in the long run. Again, not really user serviceable per se, but hey, if a capacitor blew up in here, you could probably replace it yourself and get this thing to work. Something I didn't mention on the welder, a lot of these components appear to have a clear coating on them, which is good. That'll help keep that metal dust off of components, causing it to short out. This, more so than the welder, appears to have silicone or some form of shmoo, as it's called, to hold components like that capacitor in there. I know you can't see that well, but just to keep stuff from rocking and breaking off of where it's mounted to. So that's really good as well. Again, nothing too janky in here at all. I like what I'm seeing, and at least some thought was given to the design of it. It's not just a box of parts that you would expect to find off of Amazon, nor should it be for what they charge for this. All right, well, let me reassemble this and let's do some actual testing on this. So the first test I wanted to do is to look at the open circuit voltage, and this machine is rated at 91 volts open circuit, and sure enough, it's at 91.6 volts open circuit. That's actually pretty high. Your average welder that you might have at home that's stick probably is around somewhere between 40 and maybe 80. So 90 is high. Now, the benefit to high open circuit voltage is it's easier to strike an arc with sticks simply because you can get somewhat further away and it will actually start the arc for you. It's easier like with a 7018 when the tip has got some crap on it, you can generally arc through that easier. So open circuit voltage being above 80 is good in the sense it's easier to strike an arc. And by the way, if your machine is difficult to strike an arc with, the open circuit voltage is probably too low. It's probably like 20 or something. Now, they do make a version of this with the VRD, the voltage reduction device. What that does is it essentially lowers the open circuit voltage to 14 volts. Now, the difficulty with that is depending on how they do it, it might be difficult for it to strike an arc. Now, if you're a skilled welder, it won't matter. You'll still be able to strike it, but it will be a little bit harder. The benefit of that, though, is that you're much less likely to become part of the circuit. At 91 volts, if your hands were soaking wet and your stinger was bare copper or something, you'd probably get lit up by this thing. But again, if you wear your proper, PPE, your proper stick welding gloves, and you're smart about things, you'll probably be okay. Now, interestingly enough, because this runs on a battery and it does not take AC power, rectify it to DC, its output while stick welding should be about as clean as you could possibly get for DC output. That's something I talked about in other videos, and I'll put a link in the description on one that you might want to watch where I talk a little bit more about that. But needless to say, this DC output of this should be as clean as possible. The only thing that would probably rival this and be close would be like an old engine drive that had a DC generator on it. Those also output very clean DC. In comparison to your average stick welder, the DC on those is far less clean. It has quite a bit of ripple in it. And for the sake of stick welding, it really doesn't matter. but you can notice a difference when you go to an absolute pure DC source that's very stable versus an unstable rectified AC. Anyways, what I'm going to do now, because we're at full battery power, I'm going to set this sucker aside, do some welding, I don't know, 5, 6 rods or something, and then I'm going to put this on a charger, and we're going to monitor how much power consumption that this has while it's charging. Well, that idiot's welding in the background. Let's talk about the machine's output. I did not expect to find this kind of a waveform on its output. So what we're actually looking at is essentially a square wave DC output. Now this is monitoring voltage. We have a difference between plus 9 volts and plus a bit over 30 volts. This is not me manipulating the arc length that's causing this, because if you look at the frequency tab, this is done at many thousand times a second. As a matter of fact, the cycle time is somewhere around 21 milliseconds, so this is extremely fast that it's manipulating the voltage. Now, I have a feeling it's also manipulating the current output, and it's doing so in order to control the output. More on that in a little bit. But keep in mind, we're zoomed in. If I zoomed out on this, that ripple that appears to be like mountains and valleys would basically more or less disappear into a straight line. So the further you zoom in, the more details you see, the higher the resolution. But with that said, it's actually not pure DC output in the sense that it's a flat line even at a zoomed in. It does have a cycle to it, and there's probably a good reason why they're doing that. All right, let's move on. So imagine that I was wrong. I'm wrong more than I'm right, but that's the point of learning anyways. So we saw evidence on the output that it's not just straight line DC, which is what I expected to see. And I sat and thought for a minute, like, okay, I'm wrong. Clearly I missed something, or I didn't think of something, and I kind of had an epiphany, and I'm probably still wrong. So if you feel I'm wrong or have a better idea, feel free to leave it in the comments. But what I think is happening is we have a battery pack here that's obviously DC. Okay, you can't store AC current in a battery. So it's DC, and to adjust amperage output, how can we do that with electronics? Well, one way would be to use like some sort of a resistor to resist the massive current that we could pull out of the battery to control the output. But what's the problem with that is that, well, it's going to waste a lot of energy in the form of heat. And when we have a, battery that is not being replenished, we don't need to have the inefficiency of losing power to heat. So what I believe that they're doing is they're using some form of a IGBT, MOSFET, something, and what it's doing is it's switching the current on and off very fast, and kind of like a VFD of sorts. And by controlling how long that pulse is on for, it's capable of controlling the output, if that makes sense. So to you and I, as we're welding, we don't see any difference because it's happening so many times per second. It's extremely fast. We don't notice it, but it's able to control output simply by controlling the width of how long or the on time that it's on. That's kind of my thought. Now, I notice like when welding, it seems to be different. Like the arc is completely different than any other stick welder I've used. And that's probably why. I thought it was purely DC because of how smooth it is when I weld, but it must just be that the electronics that they have controlling this are just really good, because just with 6010, which I ran a bunch of it, I ran like 5, 6 rods and a couple 7018s, it just ran smooth, ran good. I like it, but it's still a modified form of DC. It is not purely DC, so I was wrong again. Interesting. So what I'm going to do is we're going to hook this up to a meter, and I'm just going to set it for quick charging. We're going to monitor the wattage and the amperage, and then after it's remotely close to fully charged, which by the way, it only pulled 1 bar off of it doing all the welding I did. Once it's fully charged, I'm going to set it to charge while I weld, and I'm going to run a 7024 at 150 amps. It's max output, and we're going to look at the worst case scenario for current draw. All right, so right now this is monitoring what that active charger is actually pulling and consuming to charge that battery pack. It is not in the higher version of quick charging, so we're just charging at a normal rate. It is consuming 568 watts, or about 7.25 amps to charge that at a normal pace. I'm going to up it to the quick charging mode, and let's see what it takes. So it's up to about 9 amps, and it is consuming about 710 watts roughly. Its power factor is pretty good at 0.73, so for a charger that's really not that bad. Poor power factor basically means that it has a lot of reactive power. Now this consumes so little power that the reactive power is of little concern. When you're dealing with welders with poor power factor, it can end up to breaker trips really bad despite it not really needing that much power. So the consumption is really low for quick charging, which is good because you'll be able to weld like off the grid per se, and then go back and charge it at least on very, very little power. Now I'm going to let this charge for a little bit longer, and I'm going to run a couple beads, and we're going to see what this actually pulls while it's welding. So now I'm going to put a little bit more demand on it, and I'm going to run a 7024 at 140 amps, which is the low end of what 7024 would run at. Now the machine, I forgot, it only goes to 140 amps with stick, even when it's on the active charger, not 150. It can hit 150 with TIG. All right, let's fire this up and run it. Well, I gotta say, it's pretty cool that this charger is able in a normal charging mode to draw such little current, because it gives you an immense capability to at least charge this on, say, a solar array or something if you're out in the middle of nowhere. It's not like a normal welder where you kind of need 20, 30 amps of 120 volt power to do anything with it. At a bare minimum, you'll be able to run a bunch of rods off of battery power only, and then on the slow charging to be able to run the charger at under 10 amps. That's pretty awesome. Off the grid welding with this, I think, is probably more doable than with any kind of other setup, simply because of that fact. Now, had the battery been fully depleted or 80–90% depleted, I'm sure this charger would have output a lot more current, and that's where you would need a lot more powerful of a power source. They claim a 2,000 watt generator would run it. I have no reason to doubt them on that. So very minimal power. And like I said, you can always just go to the normal charging rather than quick charging, and rather than the combined charging, and on very little power charge this. So pretty awesome setup. And like I said earlier, I've used this for quite a few jobs already, and it's very handy. I don't regret the purchase one bit, and you'll probably be seeing this in more videos in the future, because I got a couple jobs that I'm going to be doing remotely in the middle of nowhere, and I don't really feel like lugging a big generator around when this thing will do it. Pretty cool technology. I just wish it was more affordable and more readily available for all of you guys, because this type of welder, I think, is going to become more and more popular as battery technology improves and as the costs go down. I would like to see something like this in the $1,500 to $1,800 price range, because at that point, I think a lot of you guys that are home hobbyists and stuff would be more interested in it than at the current price point it's at of over $3,000. It's kind of unfortunate, but for certain jobs it's more than justified, especially the TIG end of this. I mean, amazingly capable. Well, with that said, thanks for sticking around. Until next time, guys.